All right, let's get into part 2 of this trig ratios and our unit circle. So part 2 is directions. We want to determine all 6 trig ratios given the angle measure. So again, doing exactly like what we did the other day, or just yesterday actually. Let's move up to our unit circle and let's find negative pi over 2. So negative pi over 2, let's find it on our unit circle. Remember that we are going the negative direction, which means we are going to go clockwise to find pi over 2. If we go counterclockwise, pi over 2 is here. This is our 90-degree angle. So if we go negative pi over 2, that is also going to be our 90-degree angle down here, below our x-axis. So those coordinates there are going to be 0, -1. Remember, the unit circle means we have a radius of 1. Anything on our x-axis or our y-axis are going to be either 0, 1, or 1, 0, depending on what position we're in on our unit circle. So we are down here, negative pi over 2, 0, -1. Those are our values for our cosine and sine. So we have cosine of negative pi over 2 is going to be our x value of that one, which was 0. Our sine of negative pi over 2 is going to be 1, or -1. We went down negative, so -1. And then our tangent value of negative pi over 2 is going to be sine over cosine. So sine is -1, cosine is 0. Well, what is -1 divided by 0? Remember, you cannot divide anything by 0. So whenever you have 0 in the denominator, this is going to be what we call undefined. All right, so tangent of negative pi over 2 is undefined. Let's do secant of negative pi over 2. Secant of negative pi over 2 is 1 over cosine. So 1 over 0, because that's cosine, 1 over 0, again, is undefined. All right, and then cosecant negative pi over 2, 1 over sine. So 1 over -1, easy peasy, that's just -1. All right, now let's look at cotangent of negative pi over 2. This is where you want to use not 1 over tangent, because 1 over undefined means nothing in this world. So we want to look at cosine negative pi over 2 over sine of negative pi over 2. All right, remember that cotangent is 1 over tangent or cosine over sine, which means we have 0 over -1, which just gives us 0. And that's a value that we can work with. So here's your 6 trig ratios. B is going to be 2 pi. We want to figure out all 6 trig ratios with 2 pi. So cosine of 2 pi, sine of 2 pi. I'm going to write these down before I scroll up to look at our unit circle. Tangent of 2 pi, secant of 2 pi, cosecant 2 pi, and then cotangent of 2 pi. All right, so here's our 6 trig ratios. Let's determine what the coordinates at 2 pi are. If we go counterclockwise, because it's positive, 2 pi, so if we go halfway, that's pi. If we go all the way in one complete circle, we're back at 0, or we are back at, it's 0 or 2 pi. I don't know why I crossed it out. 0 or 2 pi. So one full circle will be 2 pi. And then those coordinates are 1, 0. So let's use those down here. It's too far, Miss Enriquez. So our coordinates are 1, 0, which means cosine is that x value, which was 1. Sine is the y value, which is 0. Tangent of 2 pi, sine over cosine, 0 over 1, which in this case is just 0. Secant is 1 over cosine, so 1 over 1, which gives you 1. Cosecant is 1 over sine, which is 1 over 0. What happens when you have 0 in the denominator? You get undefined. All right, this will make more sense when we get into graphing next week. So keep these things in the back of your head. That's why we're doing them this week as a review. And then we'll get into graphing next week and show you how to actually use this in graphing. But let's go into cotangent of 2 pi, which again, use that cosine over sine. So cosine over sine is 1 over 0, which again is undefined. All right, let's go into part 3. Given one trig ratio and the quadrant, find the indicated trig value. All right, so we are given sine of A is negative root 119 over 12. A is in quadrant 3. Find secant of A. So what I like to do for these ones is draw a picture. Start with, let's do on our unit, or just a quadrant, or all 4 quadrants. Remember that this is quadrant 1, quadrant 2, quadrant 3 lines. Remember this is in Roman numerals. I don't know if I mentioned that, but these are in Roman numerals. And then quadrant 4. So we're down in quadrant 3. So let's draw a triangle down in quadrant 3. If we draw a right triangle in quadrant 3, A will be our reference angle. Remember, your reference angle is from your x value, or your x-axis, to the terminal side of that angle. So angle A is going to be the angle that's closest to your x-axis. Now, we know sine of A is negative root 119 over 12. That means opposite over the hypotenuse. So opposite of A is our negative root 119, and then our hypotenuse is 12. The reason that I know negative 119 is the negative value, sorry, this looks a little funny. What your actual work would say is having the negative here. I know that this is going to be our negative side, because if you look at our y value, we're over in quadrant 3. We know sine is always negative, meaning our y value is always negative, or this length is always negative. Your hypotenuse is determined by these 2 legs, right? So that means that our x value here is also going to be negative. All right, so you're not going to have a negative hypotenuse, you're just going to have your negative legs. Okay, so now we want to figure out secant of A. We know secant is 1 over cosine of A, or that means that we're looking for our hypotenuse over adjacent. So remember, if you guys, let me scroll up for you. Sorry, this is going to be a lot of scrolling. Remember that we are looking at, we're trying to find the secant of something. So we know it's 1 over cosine, or we know it's the hypotenuse over the adjacent, the reciprocal of our cosine ratio. So hypotenuse over adjacent, let's figure that out in this problem. Okay, so according to A, we know opposite, this is our opposite. Adjacent is over here, that is our x value that we need to find. And then we know 12 is our hypotenuse. So how do we find that adjacent side? Well, you have to use what you remember about the Pythagorean theorem. Whenever you're given a right triangle, those 2 legs squared are equal to your hypotenuse squared. So the sum of the 2 legs squared equals a hypotenuse squared. A squared plus b squared is c squared. So let's find x. X squared plus our negative square root of 119 squared is equal to our hypotenuse squared, which is 12 squared. All right, then let's solve x squared plus, well, these will cancel out. This will become positive, so 119 is equal to 12 squared is 144. Subtracting 119 from both sides, x squared is equal to 25. Take the square root. Remember, whenever you take the square root, x can be equal to positive or negative of that number. So square root of 25 is 5, but it's also negative 5. In this case, if you guys are looking at which quadrant your value is in, we are over here in quadrant 3. Both our x and our y values are negative down here. All right, we're on the negative side of our x-axis, so we are actually going to be looking at x equals -5. All right, so that's our adjacent side is -5. Because we're in quadrant 3. And then we want to find secant of A. So secant of A would be the hypotenuse over the adjacent, which looking at this, your hypotenuse is 12. So that's 12 over the adjacent is -5. And that would be your solution. All right, so you guys can use this method as well for finding your 6 trig ratios from above. You guys can use this method as well. You guys can always draw your unit circle and determining which quadrant you're in and using triangles to solve these. So let's look at secant of A is 14 over the square root of 171. A is in quadrant 1. Find cosecant of A. So let's draw our quadrants. We are going to be working in quadrant 1. So if I draw my triangle here, here's our triangle, here's our A value. We know secant of A is 14 over the square root of 171. Remember, secant is hypotenuse over adjacent, or 1 over cosine, so we know our hypotenuse is 14, and our adjacent is square root of 171. All right, we are looking for cosecant of A, which is hypotenuse over opposite. So we need to find this opposite side over here. I'm going to label it y because that's our y value on our coordinate plane. You guys can use x. That's totally fine too. You're just trying to give it a variable that you need to solve for. So let's use the Pythagorean theorem. Again, we know the square root of 171 squared plus y squared will be equal to the hypotenuse squared, so 14 squared. All right, simplifying this, these will become 171 plus y squared is equal to 14 squared, which is 196. Subtracting 171, you get y squared again is equal to 25. It's not always going to be like this, just in this problem. That's what we got. Square root both sides, you get y is equal to plus or minus 5. Again, here, is it positive 5 or is it negative 5? You have to look at which quadrant you're in. We are in quadrant 1, which means both x and y are positive, so we are looking at y is equal to 5. All right, using this, how can we determine cosecant of A? Cosecant of A will be the hypotenuse over the opposite. Hypotenuse is 14, opposite is 5. This will be our value of cosecant of A. All right, so you guys are going to be entering these things onto delta math. The way that you guys are going to use a fraction symbol on delta math is if you guys were typing in this as your answer. So on delta math, you're going to be typing in that / underneath the question mark symbol on your keyboard. So use this as a fraction. Use this to get a fraction. Or to create a fraction. And then you'll just click on the numerator, click on the denominator, and enter in your values. All right, again, questions on this, go ahead and post it to our discussion board this week.